So, good evening, everyone. Today we are discussing the one sort of all the DSA pattern used for the online assessment. So, I'm using my personal notes to discuss with you. Let's see. Starting with the sliding window, let's see how you recognize the pattern and how you solve the problem. What is the approach? How you identify the problems types and some basic question. We simply don't solve right now. We simply discuss all the topics and the variation. Okay. So let's start with the one of the starting topic for the DS series, sliding window. So let's start with the sliding window. Where is it is? We'll start. So okay. First topic one. Topic topic one is sliding window. Sliding window. Okay. So what is sliding window? So sliding window is a technique. So actually, mm, sliding window is a technique to reduce the time complexity of problem involving for the continuous subarray, like sum, max, mean, or count everything. So it is a technique. So what is technique? It is a technique to and solve and reduce the time complexity. Okay, solve and reduce the time complexity. Okay, and reduce the time complexity of the problem involving the several things like everything will be covered here. So how when to use this sliding window problem? The problem involve a subarray or the substring things. So when to use when the problem have a subarray things like subarray subarray things, and we have to ask the mean, max, max, sum, count. We count the window of size this, and in this case we have to use sliding window. So how to identify it is the input is linear structure, and the does this need to look all the subvariant substring for the given size of the range? Can the next state be derived from by removing the left element and the adding the right element? Ask to find maximum and minimum, sum, count, length, index, everything. Use two pointer that help to track the window. Okay. And do you need to shrink or expand the size? So expand the window, we have to decrease the window. In this, expand the window, expand the window when when we don't meet our requirement. Okay. And shrink the window when we exceeded anything. So exceeded our limit. So exceeded our limit. Okay. Our limit. Okay. So these are the two type of sliding window. So another question, there are two type of sliding window. So let's see, there's two type of sliding window. One is dynamic one and one is fixed one. So fixed sliding window, and another one is dynamic sliding window. Okay, sliding window. Okay, one is fixed size and dynamic size. We according to our needs we expand or decrease the size of window. So slide one step, add new slide in dynamic. Sliding window simply mean that sliding window simply mean that mm, slide slide one step Add one step, add new, add new, and remove old. Okay, remove old. Okay, so simply the template for this. So let's discuss the template for the fixed sliding window. Template for the tem template for the sliding window, fixed sliding window. So what is the template for the fixed sliding window? So let's see. Let's template for the fixed sliding window. So simply we have a for loop in starting from I0 to I less than n I plus plus, and the add the current element to the window. So if I is greater than is equal to k minus 1, in this case process the window and remove the element going out of the bound. Okay, so this is a template. So let's see one example. Maximum sum of subarray of size k. So okay, so in this case how we write a maximum subarray? Simply we do window sum max sum I02 less than n I plus plus window sum at this element if I greater than k is equal to this k minus 1. At that time we have to find the maximum sum, and we remove the extra element from the window. Okay, and variable sliding window. The window size change dynamically based on the condition. Use two pointers left and right, and expand the right if the condition break, or shrink the window. No, expand the right if condition breakage, or shrink the left one. Okay, the template for the uh, template template for dynamic sliding window. So in this case use the template like solve solve using this. So initialize the left equal to 0. Okay, and only the right pointer move. So right till 0 and IGST. Simply write note as R. So R is equal to 0, R less than N, or R plus plus. In this case, expand the window including, firstly we expand the window by including the nums of right value. So in which including nums of R value. Okay, and till when? Till when? While condition is not violated. If condition is violated, if condition become violated, in this case what we have to do, we have to shrink the window. So in this case we have to shrink the window and left plus. Okay, after that whatever you want to return, simply return these things. So in this case we have to return this side, so R minus L left. Okay, and dynamic slide window. So whenever we see the longest substring without a repeating character, so we initialize left is equal to 0, int n is equal to s dot size length is equal to 0, max length is equal to 1, right starting from the 0 count is 0 if n is equal to 0. If the size of the string is equal to 0, then in that case we have to return 0. While right move till end for including everything value, int I starting from the left and go till right. If we check if s of right is not equal to s of I, in this case we increase the length and we analyze the max length. In another case we have to simply increment the left and break. Okay, so these are the sliding window things. So we cover the intro and everything for the sliding window. Let's try to solve the question on the sliding window problems. So um, So okay. We have the following question based on sliding window. So let's see what are the question based on sliding window, fixed sliding window. So let me assignment of DIP. So fixed sliding window in which let me uh, fixed sliding sliding window. So window. So here are the list of questions. So a substring of size 3 with the distinct character. So in which a size is given. So here is the first question. Considering first question. The substring of size 3 with the distinct character and substring of size 3 with distinct character. So in which the size k is fixed. Substring of size and substring of 3 size. This one is the first question on based on fixed sliding window. Find all anagrams in the string. Find all anagram in the strings. Okay. After that, we move to the permutation on the string. So permutation, permutation on the string and string. After that, we take max length of a vowel, max number of vowel in a string of given length. Max number of vowel. Okay, vowel in a substring of given length of given length given length. Okay, given length. Max number of vowel in a given length, and also find the maximum average array. Maximum average array. Maximum average array. Average array. Like maximum average number of k. Okay, sliding beauty, sliding medium. So these are the things maximum point. So through this question, from these all 5 6 and 7 question, you understand the basic of all fixed sliding window topics. Okay, so let's copy this one. Okay, net is not working that much. So in this question given a substring. In this question, given as string is a good if no repeated character. Given a string of s, return the number of good substring of the length of 3 in s. Note that there are multiple occurrence of the same substring. Every occurrence should be counted. A substring is continuous, so we have to count. We have to substring of the size 3 with distinct character. Size of 3 distinct character. Yes. So the input is given like this. So for the first question, we are given with this question uh, substring. So we move this slide window. So uh, x y in this question. So x y z of side 3 distinct. Okay, y z z is not distinct. Z is not distinct. Z is not distinct. So only one character is there. So what we have to do, as we see, what is the pattern? What is template for this? If we I increases the k minus one, we have to return the answer. So max number of the count. So mm, simply in this case, what we have to do? Mm, in this case, we have simply int n is equal to string dot size. Okay, string dot size. Mm, okay, count d count d. So put into the set. Mm, another set. Let's create an another set. Order character of st. Okay. For loop int I starting from the 0, I less than I plus plus. Okay. I plus plus. Uh, simply we have to put uh, simply have to put the value. Mm, stable. Why simply intuition is simply here can't dot access dot html. Unordered set st. Let's create a string, this one string type. Okay. So okay, I 0 to n, I less than n. So what to do? So another set. Mm, mm, so in this case, uh, string like what w s dot sub str of I comma I plus 3 size fixed I 0 1 2 0 1 2. Okay, value is fixed. Okay, so we done this loop till n minus 2. If it crosses that limit, and put the value in the ft dot insert what w and uh, mm, okay, unique element. Okay, no. Putting every element in the set. Okay. mm, every time we have to do and don't take every words. Okay, each character and okay. mm, try to solve using another map. So what we do in another map, int I is equal to 0, we have to initialize int j is equal to z equal to 0 and unordered map M or that map of what character comma we have to count the value character comma empty. Okay, final answer will be stored in the this one vector while I less than n. Okay, now so j less than n. Run this loop. Mm, so empty of s of empty of s of j plus plus, the value is given inside there. If j minus I plus 1 is less than 3, so in this case we have to increment the j value, increment the j value, otherwise else else if empty dot size become is equal to 3. In this case answer plus plus. In this case we have to answer plus plus and answer plus plus and erase the dot erase empty dot erase s of I and I plus plus and j plus plus. Okay, else rest of the condition in which we have to empty of s of I minus minus, and if empty of s of I, if empty of s of I becomes 0, so in this case we have to erase. So empty dot erase the value of what s of I and else and if condition, or simply have to I plus plus and j plus plus. And finally we have written the answer. So lastly we have written the answer. Okay, accepted. What we did, as the size I and j another map answer, I run this one. If simply put the value inside the map count. If I and j value is less than something, so increment the value. If mp dot size is equal to 3, that in that case we have increased the answer and I plus plus and j plus plus. Okay, or else case, if many of these elements included, so we will simply decrease the left value. Okay, left value, and if mp of s of I 0 becomes 0, then dot erase, otherwise we have to erase this one. So this one is a simple question on this fixed sliding window. So move for the next question. Another case, so simply another example is find all the anagrams. So find all the anagrams in this sliding window. So all the anagrams. So, you are given a string. So it is, this one is already solved, so we only discuss. You are given a string as np, return an array of all start with indices p in is an anagram of s. So you may return the answer in an array. So example, let's see. You given s and p, return an array of all start indices of p, or starting index of p, starting index of p anagram in s. Okay, you may return in an array. So p size is fixed 3. Let's check three sides of. Is this is anagram count? Count the value of ABC and ABC dividend. So starting value will be 0. So simply we check sliding, run the sliding window. So in this case, this one, this one. So the substring with the starting window will 0. So ABC is anagram. Anagram is the number of element. Listen, this is C D A. What is anagram? So in this anagram is, let's see, anagram means this anagram like this: ABC, ABC, A C D, yeah, C D A. स्ट्रीम का स्टार्टिंग क्लिप देख सकते हो, उसमें मैंने सॉल्व बोल चुका है, हटा दूंगी. The number of element is constant in every substring. So this one is anagram. So how we find? We simply check how we find. Simply run the sliding window, count each of this length. So as having the S length, so M for P length. If n is less than, if n is less than P, the size of S is less than the size of P, this minute we return the result, anything we have. So the answer will be stored in the vector. So we also return the vector. So storing the character of S, we create a vector of int S count of size 24, 26, comma 0. So we have to store the all the count of character A, P, P count of this. We run the loop and count everything. So how we count? P, P of I minus A plus plus. In this we get the count of A, B, C, D in the element. Okay, in which if P count is equal to S count, if P count become S count, if P count become S count, in that case we put the result is 0. So int M, the starting value of M to less than N. Okay, so S of I minus M minus A minus minus, and this one is plus plus. So if both value become equal, we have to push the starting index. Okay, and finally we have to return the answer. This one is also a simple one. So let's move for the next question. Permutation. Permutation of the permutation. Permutation. This one is already solved. So you're given as two string S1 and S2, return true if S1 contain the permutation of S1 and S2 contain the permutation of S1, otherwise false. In another one, return true if S1 is S1's permutation, a substring of S2. So S1's permutation inside this. Okay, we have to check the count. Simply this one similar as the previous question. We have to simply count the element exist or not. Okay. S1 length is greater than S2 length. In this case, we have to return false, and otherwise we have to store the all the element vector. Count the all elements character inside the another map. So create another map for the S1 count and S2 count, and starting with the counting the value of S1 and S2, S of I plus plus, S of 2 of I plus plus. So if S1 count become S2 count, return true. Okay, and start with this one is little bit dynamic. sliding into column. Left is equal to 0. Right from the S1 left after 4. Hmm?